Hello, my name is Grace Lee, and this is Projectile Motion. So, what is projectile motion and drag force? Projectile motion can be defined as the motion of an object thrown/launched into the air. It moves along a curved path because of gravity, and it also has parabolic motion with the absence of air resistance, aka no drag force. So, what is drag force? Also known as air resistance, it opposes the direction of motion and it slows down the object. So some important formulas for this lab is the velocity update formula, and instead of A, it can also be written as F net over m. For the position update formula, 1 half at squared is irrelevant as there is no horizontal acceleration. So for this lab, it will be used as x final equals x initial plus velocity times t. Finally, the drag force equation will be used to calculate, the drag force. The purpose of this lab is to examine the properties of projectile motion, examine how drag force affects projectile motion, and observe how the magnitude of drag force affects projectile motion. Like last week, two programs will be used in this lab. GlowScript, it helps with visualization and simulation, while Tracker tracks movement and calculates the x and y components of the velocities. As a preview to our results, it shows that our results are more in line with the simulation with no drag force. For some logistics of our lab, the system is the wadded up paper ball. The surroundings, aka what acts on the system, is the earth and the air. The wadded up paper ball has a mass of 0.0025 kilograms, and the ball was obviously wadded up. The ball was then thrown into the trash can as the video was recorded, as shown here, as this is the tracker. The video was then put into a tracker, and manual tracking was used for accuracy. And the origin was put at the trash can in order to avoid any negative Y values. After tracking the data was subsequently put into a Google spreadsheet. From there, four charts were made: the position X time graph, the velocity X time graph, the position Y time graph, and the velocity Y time graph. These four graphs are necessary in order to convey the motion of the wadded ball, as shown here, and the purple line is the best fit line. After the experiment, GlowScript was used in order to simulate this exact scenario. Quantities such as the mass, velocity, time, and g were put in. The proportionality constant was also initialized for the drag force, b0, for now. Formulas to calculate the forces along with updating the position/velocity were also added. And these are all the things being put in, and these are all the formulas used to calculate. So for the first trial in the simulation, the proportionality constant was set to 0, and this essentially represents no drag force, shown in these graphs right here. For the simulation second trial, B was increased to 3. There is now some amount of drag force present in the equation now, and the x component is no longer linear, and the y component takes much more time to decrease in value. Finally, the proportionality constant was increased to 5 for the third trial. There is now even more drag force present in the equation now. The x component is even more less linear, and the y component takes much more time to decrease in value. So regarding the discussion, based on the actual experiment and the model, the simulation that most closely matches the experiment was B equals 0, aka no drag force. This means that the experiment showcased projectile motion without the interference of drag force. This may have been caused by the ball's relatively small surface area, causing it to have little/negligible drag force. Some possible errors in this lab are incorrect throwing technique and human error with tracker. However, these errors do not pose a significant challenge as the tracker was started as soon as the ball left the thrower's hand, and the data, while still not perfect, still followed a general trend that fit one of the simulations. So regarding a what if question, what if imagine if the object were initially thrown straight up with the same initial speed as your experiment? Would the time this object takes to reach the ground or floor/table be the same, longer, or shorter than the time that it took in the original experiment? Well, they're the same. For both cases, the only component that has the acceleration is the y component. Because both components have the same initial velocity and the same acceleration, aka g, they will hit the ground at the same time. However, they will not be in the same position as the one thrown horizontally will be farther away. And this is supported by the final velocity equation. Thank you.